I'm about to start the next lesson. I've opened it. Very short? Do you have a calculator?
Yeah, I did 3 times.
This is... Oh, but you need... Can I have a pen? It might help if you put brackets around the upper. You know what I mean? And around the lower. On the calculator. It might help. Okay. We'll continue now. You can look up, please. Look up. Huh? We will. We will. I think you can handle it. You look like a strong class. There are some weaknesses though. Alright. So, why is the definite integral important? Well, it turns out that the definite integral is important because it lets you calculate something. Yes. If you have a function, let's say fx, and this is x, and this is y, and let's imagine here is a, and here is b, and I would like to know the area. Just before that, what does the derivative represent? Do you remember?
Slope.
Slope. So for example, the derivative tells you what the slope is, but the integration tells you what the area is. So this makes integration very important, because when we want to calculate areas on graphs, we can use integration. So for example, here, this area will be integrate a to b fx dx. Now, it's important that the fx is positive, and we'll look at a situation when it's not in a moment. But first, let's do an example where we know the answer. So, for example, let's take something very simple like this. Y equals just x. And this is the point 0, and this is the point 2. So, what's the y here if x is 2? 2. What shape is this? Triangle. So, what should the area be? 2 in total. A half the base by the height. Let's check that we get 2. Integrate from 0 to 2 x dx. Integrate x, what do we get?
X squared over 2.
From 0 to 2.
Yeah.
That will be 4 over 2 minus 0 over 2, which will be 2. I know, amazing. So let's do an example where we don't know the answer, but this is our first example, if you can write this down.
What is the name of this?
Area. Good.
Do we have to, in the exam, do we have to show that the area of the line?
Usually in the exam they give you the graph and they ask what is the area of the shaded region. So often, I think in every question I can think of, they shade the area in on the graph. What, Faisal?
Just me and myself and I.
Great.
What's
Wait, go ahead Ian, yeah.
like, can we just show, like, subtracting like two areas, can we just like subtract it by the two equations and get the area and then show them? Can we talk about that?
Yeah.
I think I know what you're saying. Yes. There are more difficult examples we'll have to do now where we'll have to start subtracting things. Okay, continue. Area.
Do we do trapezium?
No. Well, we do in semester 2.
Can we use this for all types of areas?
Yes, which is why it's so important and useful.
Like, can we use it in physics?
Yes, but we never have problems in physics where we need to use it because they're not difficult areas. But yes, we could use it anywhere. Okay, continue. So let me give you one to try, another simple enough one. Thinking of a question. I know what I'm doing. Yeah. Right. I want you to calculate the area shown in the picture. Give me this area. I know, I did that on purpose. You'll have to find them yourself first. So. Do I need to tranquilize you or something to start a class? I just want you to tone down a little bit. Got it? Yeah. You have an answer? Yahi, what do you have to do first to start it? Huh? Yeah, very first thing you need to do if anybody's stuck is you have to find, what are these points called? Oh, no, what are they called? Let's have a look. What were the roots here when you found them using factorizing or quadratic formula? 1 and 2, yeah. This was 1 and this was 2. Yes? This is what you got? Yeah. So, look please. The area is the integration from 1 to 2 minus x squared plus 3x minus 2 dx, which is equal to minus x cubed over 3 plus 3x squared over 2 minus 2x 1 to 2. Let's put in 2 first. I get minus 8 over 3 plus 3 times 4 over 2 minus 4. And let's put in 1. Minus 1 over 3 plus 3 over 2 minus 2. That's 6 minus 2, isn't it? Which is 2. Minus 8 over 3 plus 2. Minus 2 over 3? Great. Minus... Maybe you can tell me this
6.
one.
5 over 6.
What is it?
5 over 6.
Okay. So in...
No. Oh, minus this one. Yeah, okay.
Is this right? Something seems wrong here. Is it 5 over 6 or minus 5 over 6? Oh, thank you, that's better. So that's 5 over 6 minus 2 over 3, which is 1 over 6?
Yeah.
1 over 6. That's the area, 1 over 6. Now, what's really great is we can check this on our calculator. Watch.
You know
Integrate.
about the calculator?
What?
When the go out.
Yes. Integrate from 1 to 2. Did you all see that integration button here? Integrate from 1 to 2 minus alpha x squared plus 3 alpha x minus 2. We should get 1 over 6. We do. So in the exam, we know that we got this 100% right. Okay, let's look at another similar but different problem to check the answer. Right, look at this graph. Here is point 1 and here is point 3, and I want the area here and here. Now there is a huge difference with this problem. The area. There's a big problem with this one. The formula I gave you doesn't work if you mix above and below the graph. This region is positive and this region is negative, and we cannot do this. It is not 1 to 3. No. What you must do is break this into 2 halves. So this is our next example. You must calculate, and this is the same function. You must first calculate 1 to here, which is 2. And we already have the answer for this. What is it? 1 over 6. What I want everybody to do now for me is calculate the second half, which is 2 to 3. So can everybody do this one, please? Now if you want, it's kind of the same as this, so you can kind of just, jump to this step, but just change the limits here. It should be 2 to 3. See what you get. Come on, Omar. Did you get an answer? See?
Here?
Please. Yeah. Okay, what did you get, Yusuf? Minus 5 over 6. Anyone else? Yeah. Minus 5 over 6. Let's check the answer. So the only difference is this is a 2 and this is a 3. And you get minus 5 over 6. Now here's the problem. Area cannot be negative. Area must be positive. So what you need to do is fix this by changing it into 5 over 6. So the final answer is 1 over 6 plus 5 over 6, which equals 1. So this is the correct answer at the end. So the problem here is you need to change the sign at the end. Yes. Okay, one more example to do here. Can I scroll down? Yes? Right, let's have a look at this one now. This one is y equals x. Sorry, I'll use colours. This one here is y equals x, and this one here is y equals x squared, and I want this area. Okay, so the very first thing I want you to do is I want you to tell me what are the 2 points here and here. Write it down. I just want the 2 points first. Okay, so we want to find where they meet. So that means we want to solve this equation and this equation. What's the best method here? Substitution. So we get x equals x squared. X squared minus x equals 0. X times x minus 1 equals 0. So the two values for x are 0 or 1. So this is 0 and this is 1. Now, the area is a bit different here. In the previous examples, we were looking at area under the curve with the axis. But that's not the case here. In this question, we want the area in between two curves. And the way to calculate that is not very different. We still integrate from 0 to 1, but the big difference is, because we have two curves, we must use both of these. We must use both the x and the x squared. What we do is we write the bigger function first, so that's the red function, which is x, and then we minus the lower function, and in this case the lower function is x squared. By integrating this, we get the area in between, and that's all. Yeah? The bigger function minus the smaller function. Question?
How x squared is smaller than x?
Because the graph.
The graph on top minus the graph on bottom.
Yeah. It's only smaller between 0 and 1, which is all we care about. They swap places afterwards. I feel questions. Questions? Yes. One sec, yeah?
How do we know one function?
From the graph, which will be provided in the question. You could just put in 0.5 into the functions to see which is the higher of the two. It's never happened in the exam where the function switches places. So there should be a clear region where one is higher than the other. So just to put it as a rule, look, if this higher one is fx and this lower one is gx, and you want the area here from A to B, the area is integrate from A to B, fx minus gx. Because if you think about it, fx minus gx gives you the heights, which is what you want. So, or, no, that's crazy. That's the way you learned it in high school, which I think is crazy. Do it my way. I'm a very lazy person. You can trust me to find the easiest way to do it. Trust me. Okay. Can I go back? Yes? Right, now it's not so difficult. Let's calculate. What does x become? That's x squared over 2, and this one is x cubed over 3, 0 to 1. That would be 1 over 2 minus 1 over 3 minus 0 minus 0. So the answer is 1 over 6. Let's check this on the calculator. Integrate from 0 to 1 x minus x squared, and we got 1 over 6. Okay. So there's 3 situations that you deal with in the exam. Can I scroll down? So, well, I suppose 4 situations really. The first situation, listen please, Karen. I know you're working together, but not when I'm talking, please. So the 4 situations are simple integrate from A to B. The second situation that you could get in the exam is when we have a positive and a negative. So first we must integrate from A to B and then B to C. The third situation is when we have 2 curves. So we integrate from A to B, F minus G. And the last situation, which I won't do because it's not really anything different, is when we have 2 different functions like this. Maybe here is an F, and then here is a G, and this is A, this is B, and this is C. So this one here will be integrate AB, yeah, F plus BC, G. What you're doing is you're breaking it into problem 1 and then problem 2. So these are the 4 different examples that you have in the exam. These are the 4. This one, they never really give this one in the exam, it's too easy. The 2 that they like to give in the exam are these 2. Because this one's too easy and this one's a little bit too easy as well. But sometimes you get this one. Okay. So this one here, this would be only in section A. This one would be B. This one would be B. And this one would be B. I'd say this one is like 40% of the time, 40% of the time, and maybe 20% of the time. I've never seen this in section B. It's too easy. Okay, so if you need to write that down, you can, and I'll give you homework now. Yeah, same day, same paper, same time. Sometimes you need to, and sometimes they give it to you. 50-50. Okay, homework. Yes, you have this? Patience, please. Patience. You don't know what your homework is yet. Okay. I'm waiting for 2 people. Time's running out. You're finished? Now I'm just waiting for 1 person. Right. Homework. (12 to 22). Now you can go. You are free. free to go. Me too.